very much. Wonderful to be here. I have to say, it's such a great occasion for me because I do think music is such a human thing. We're all, from the earliest days of civilization, before the earliest days of civilization, it's been clear that people have been playing musical instruments of one sort or another. It's part of who we are, and it's a great thing to actually feel that we can be part of the transition we have to make in dealing with climate change going forward. So it's great to talk with you, and I'm very happy to talk. We're going to have a panel discussion later, and I've been asked to join the panel. So if you've got questions, you might want to reserve them for when we're on the panel here. The second thing to say is it's great to be back in Zurich. I lived here 6 years and was at the ETH, and it's a wonderful place, and the Tonhalle has unbelievably been transformed. It's wonderful to see this, and hearty congratulations on this amazing renovation, and also the incredible organ, which I think was we heard beautifully. So I'm going to talk to you today about climate change. I'm going to start by just laying out the evidence for climate change and how serious it is, because I think the important thing to realise is that scientists have been talking about climate change for a very long time, but I don't think even the scientists understood how serious it's going to be. And so people haven't realised until recently how really bad this is going to be and how hard it is to deal with. And so gradually people are beginning to wake up and realise we all have to be part of the solution, and that's why I'm very keen to engage with you and others as we think this through going forward. So let me just start with a bit of geology, okay? Which may be not what you're expecting, but this shows you the deviation in degrees Celsius for the surface of the Earth as we think it's been over just the last 1% of the history of the Earth, just 1%. And that's 50 million years roughly, so it's quite a long time. And this shows you what we can tell from geology, and that is that the temperature of the surface of the Earth used to be much hotter. Okay, so this is looking back 50 million years, and you can see that it was about 10 degrees Celsius hotter. So we're worried about anthropogenic climate change and the fact that we've increased the temperature of the Earth by 1 degree. Way back in time, it was much hotter than this. And what happened, of course, was that there are no ice sheets on the surface of the Earth. So there was no Antarctic ice sheet, no Greenland ice sheet, or anything like that. As things cooled down, for reasons that I won't go into, and actually we're not entirely sure about all the details of why it was cooled down, the Antarctic started to build up ice sheets. They didn't have penguins in those days, so that's a bit of a fabrication. But the Antarctic glaciation started about 30 to 40 million years ago, we know that from a variety of lines of evidence. So I want to now show you the last 5 million years, and you can see that things have started to cool down even further on the surface of the Earth. So Arctic glaciation started about 3 million years ago, and that was the start of the ice ages that we've all heard of. And this is when we start to see hominids developing, standing up on 2 legs, and we start to see human evolution. And of course we see major societal change developing at around that time. So let me just take you now to the last 500,000 years. And to do this, I'm going to use much more precise records that we have from the Vostok ice core. So many years ago, scientists collaborated, Russians, Americans, collaborated, and Brits, on trying to retrieve ice from the Ross ice shelf, down to Lake Vostok, which you can see down below, which is more than about 3 kilometers down. And in the process of trying to get to Lake Vostok to see what was down there in the lake, they actually retrieved all this ice, and they can actually figure out from the ice record when the ice was laid down, they can figure out what the temperature was, and they can figure out what the carbon dioxide levels were. And this is shown here in terms of carbon dioxide levels. And you can see that every 100,000 years, the natural behavior of the Earth in which human society has developed has been to go from glacials to glacials every 100,000 years. And the carbon dioxide levels have ranged between 180 parts per million and 280 parts per million. That's the way things are normally. So that's what the context of what human evolution should be like and human society should be developing. And this actually shows you what happens next. And that is that through these measurements, but also through direct measurements we've got from the Model Air Observatory now, we can see, of course, that carbon dioxide levels have increased incredibly to over 400 parts per million, levels we haven't seen for 3 million years. So the reason for that, of course, is the Industrial Revolution. So this is James Watt, who patented, that's a bar in New York City, by the way. But James Watt patented with his friend Bolton, patented this new, more efficient kind of steam engine, and the Industrial Revolution really got turbocharged. And the time when carbon dioxide levels started to increase coincides pretty much with when he actually found that more efficient way of generating energy from coal. So this is the thing we have to deal with. And the first person to really figure out how this is going to affect temperature in the atmosphere, we didn't realize that she was forgotten about for quite a long time. But it was this woman, Eunice Newton Foote, who was an activist, a campaigner for rights, but she was also a scientist and inventor based in Seneca Falls, New York. And she actually published a paper on the circumstances affecting the heat of the sun's rays. She did experiments and showed that carbon dioxide had a very strong effect on the heating of the gases by the sun's rays. So nothing much happened, even though people all agreed this was going to happen. They saw it maybe as a benefit to warm up. And people in Scandinavia thought this would be great. But then we started to realize back in the 70s that actually the surface of the planet could change quite fast, much faster than people had realized before. And this stable environment we thought we were in was about to change quite dramatically. The scientists from Columbia University, Wayne Roker, who won the National Medal of Science, you can see him there with Bill Clinton, was the first person to use the term global warming in the scientific literature. And he basically said we're on the edge of something big that's about to happen, and it's going to change the surface of the Earth forever. Now, some of you may have watched Seinfeld. So Seinfeld's based American sitcom that's based in Tom's Restaurant, which is on Broadway. It's just next to where my office is. And Tom's Restaurant is a diner. It's still very popular. Everybody shows up photographs of it. But what you probably don't know is that this is owned by Columbia University. The whole building is owned by Columbia University. And right above Tom's Restaurant is the NASA Goddard Institute for Space Studies. So NASA rents the space from us. And they have scientists working on climate change in particular. And the leader of the director of the NASA Goddard Institute for Space Studies at Columbia was this guy, Jim Hansen. And in the 1980s, he realized that there was evidence now that the global warming of what he had predicted actually was already happening. And we had to get ready and change accordingly. So this is him testifying to Congress. And this is the record that NASA has been able to produce. Other agencies have come up with similar kinds of records. And they basically show they show the modeling of what's actually happened back through the last 100 years or so, and show this amazing increase in temperature. I can give you more details on this later if you want. And you can see the temperature of the Earth has increased by about 1 degree Celsius. So what does that mean? Well, it means that the ice sheets have started melting, for example. And this is data, these orange boxes show you 4 decades where they've collected data and figured out how much the ice sheets have melted in Antarctica in particular. If you looked at Greenland, you'd have similar numbers, it's roughly the same amount, even though it's a smaller ice sheet. And this is given in gigatons. So a gigaton is 1 billion tons. So it's roughly, a gigaton is about the amount of water that New York City uses in a year. It's probably similar for London. And it's equivalent to 400,000 Olympic swimming pools, if that helps you any further. And so you can see that basically the numbers have increased. They've doubled in the last 3 decades. And they're getting faster, so we're losing more and more ice, losing ice more and more rapidly from the Antarctic ice sheet. And so the rates of loss of ice have become a bit of a surprise. People didn't realize that they were actually accelerating and going at this incredible pace going forward. So we're now actually up to roughly 100 million Olympic swimming pools being lost from, of water being lost from Antarctica every year. So that is affecting sea level change, the level of sea level. And the arrows here show you where the sea level is rising and where it's going to be rising in the near future. But the key thing to understand is that the ocean is not like a bathtub. Because of the way geology works, there are places on the Earth where actually the sea level is going down, and in particular where the ice sheets are melting, like around Greenland and Alaska. They're actually losing the ice sheet. Sea level is going down because the continents are coming up after you take the weight of the ice sheet off. And so they've got different problems because they're losing the fishing industry and a number of other things. So this is a particularly big problem for the equator, though. People living in tropics are going to be heavily impacted by sea level change going forward. And the estimates are that last time we had this much CO2 in the atmosphere, sea level around places globally was around 20 meters higher, and in certain places it's likely to get warmer, and it's actually being driven, of course, by the Earth system. And so the Earth is trying to adjust rapidly to having this very large amount of carbon dioxide in the atmosphere. So if you're worried, you should be. It's going to change society in many parts of the world going forward. This is a recent report that came out from the United Nations, basically on the amount of carbon dioxide being emitted in various areas. The effects of carbon dioxide in various areas, and what the heating effects will actually likely be. And it shows you what people have been trying to point out, and that is that we have to stay within, we've already got to 1 degree, we've got to stay within 1.5 degrees. And you can see if it gets red, it's very bad. So you can see down here that the impact on warm water corals is already severe that's mainly because of ocean acidification effects. But if this goes to 2 degrees, it gets worse. And you can see that there are widespread impacts on coastal flooding. The Arctic region is going to be completely decimated. There's going to be large loss of ice in that region. The Arctic region in particular is heating up more than the rest of the Earth for reasons that people are gradually beginning to understand. The impact on a variety of parts of life can be quite severe, as you can tell. But it's going to basically be low latitude areas. There are the tropics in particular that are going to be most affected, and people are going to lose their livelihood, quite apart from the impact on extreme events and flooding. So the takeaway message from this is that climate change is actually pushing us to a world in which we've never experienced before as a human race. And it's moving fast. It's going to be going faster and faster over the coming years. So this will of course include rising sea levels. It will also affect us in terms of drought. Scientists have been aware for a while that there's a severe drought in the western United States. But now from tree ring data acquired by Columbia University and other people, the amount of tree actually grows depends on how much water there is. So you can actually look back over 1,000 years and see how much drought there was in the past and when there are episodes of drought. And we can now say that this is the worst drought in the western United States for at least 1,000 years, as far back as our records go. So it hasn't been this bad before, and we don't know quite when it's going to end, because we don't even know how far into it we are. And so people talk about the water levels in California, etc., and there are no signs yet of this being close to ocean. But there's also things like catastrophic loss of life that you'd expect from hurricanes, heavy rainfall events, and we're seeing the planet change in ways we haven't expected before, like Hurricane Harvey, where the clouds, the hurricanes slowed down, just stopped, and it's carried on dumping water. This was a remarkable thing. Nobody's seen that before. So people are worried that this will actually not just lead to loss of GDP. People are worried about loss of life. They're worried about societal collapse. And they're worried about this leading to conflict. And there's arguments to be made that climate change is partly responsible for the Syrian war, for example. So you're not going to be able to read the details of this, but this basically shows you the nature of the problem in terms of finding a solution. So that it's probably about climate change, but actually finding a solution for it is also a massive problem. So this shows you all the bits that contribute to carbon dioxide and other greenhouse gas emissions. And you can see down there in the green is land use change, agriculture, etc. But the biggest chunk is energy. And there are a variety of bits in there in orange, which won't go into detail. They include residential buildings, commercial buildings, transportation by road, as well as, of course, a lot of things to do with manufacturing and rail and ship and air transportation as well. So the tricky thing about this is that this shows you how it translates into the different greenhouse gases that we've got. Most of it's carbon dioxide. So the tricky thing about this is that you say, you look at graphs like this and you say, well, this actually looks like we're making progress. Because over the years, you can see we're moving from a situation where we use pretty much everything was coal and trees a couple of centuries ago to a situation where the coal is going down, there's more oil coming in, and the oil's going down, and gases starting to get limited, and actually the new thing is renewables. And that looks great, so if we just keep going in this direction, we'll have more and more renewables and we'll gradually take over a bigger proportion of what we've got. So now I want to show you the same data, not shown as fractions, but in terms of absolute amounts of energy. And that's shown here on the right. And what you can see is that over this exact same time span, with the same data, we're of course using much more energy. And so our usage of energy has become so important as we've increased the number of people living on the planet, as people live longer, as people lead better lifestyles, and they actually feel, well, this is great, I'd actually like to be able to enjoy a car, I'd like to be able to fly, or whatever it is. I'd like to have decent heating and air conditioning. Naturally, of course, people are using more energy. And so what you can see on the right is that while the fraction of renewables has increased, the overall use of coal, oil, and gas has also increased. And so, that means we're putting more carbon dioxide into the atmosphere. So we're actually increasing the amount of carbon dioxide into the atmosphere at the same time as we are getting these switches towards more renewable forms of energy. So this is a really hard problem, because we're being faced with the fact that people want to live and enjoy themselves. It's very natural to expect that. You want to encourage it. People living longer and improve standards of living, but actually the net result is we're using more energy and we're not moving fast enough towards renewables. So of course there's been public backlash about this, and including with the energy companies and the automobile manufacturers who have basically faced sort of rebellion from the ranks that this is actually driving the climate crisis. But actually that big graph with all the orange and green and blue, that's got bits that everybody's got to listen to. We've all got to think about what can we do to make a difference to this going forward. So this shows you how far off we are from where we thought we should be. This is a report that came out at the end of last year after the COP26 in Glasgow. There was a similar report produced before, but this has been updated. And it shows you can see the bit in brown shows you where current policies are leading us right now. On the left, we've got gigatons, those billion tons again, of carbon dioxide, counted as carbon dioxide equivalents. This includes all the greenhouse gases, so they're calculated in terms of what the equivalent would be if it was all CO2, in terms of the effect on the greenhouse effect. And what you can see is that with the latest emissions, conditional, unconditional, conditional pledges, which are in purple and orange there, you can see that actually what we've got is quite a dramatic shift. People have actually made quite a significant statement of what they want to do. The conditional bit is, if you do this, I'll do that, but I'll only do it if you do that. So that's the sort of dynamics of the international governance issue. But you can see also that we're still a long way off. This is where we are headed right now. And we need to be down here, stay within 1.5 degrees. We need to be there in 10 years. We're in the year 2030, and we're a long way off. This is the current gap that we've got to fill in terms of reducing our carbon emissions. It's huge. And so this is a problem for everyone to think about, both from the point of view that we can't actually So one of the ideas has been that could actually make life easier for everybody is that we just took the carbon dioxide out of the atmosphere. And there are people who propose that, and it's a very interesting idea. In fact, the first work on it started at the University of New York 20 years ago. And we did it with the president of Iceland, where they had geothermal fluids going into produced by the hot rocks there, the lavas. And they tried putting carbon dioxide in solution and see if it would actually disappear and form sort of part of the cement structure of the rocks down below. And they were successful. A similar kind of experiment now is being done not just with this kind of natural way of doing it, but also with actually trying to directly capture carbon dioxide out of there. This is an example in Switzerland. There are several plants around the world. And these plants are actually designed to try and get the carbon dioxide out. Then you've actually got to put it underground and store it. So these are relatively small-scale efforts. Remember, we're talking about tens of gigatons of carbon dioxide every year. So they're now starting to talk about being able to build something that might be able to get up to 1 million tons of carbon dioxide in a year. 1 million is less than a billion for what we need to do going forward. So we need to have, 1,000 of these or more of these working at scale across the world to actually do something like picking up carbon dioxide. And you've got to take the carbon dioxide and put it somewhere. And so that's very hard as well, because the amount of carbon dioxide you've got to move, all that carbon dioxide, is more than all the oil and gas lines on this planet. That's how much infrastructure has to be built to actually take the carbon dioxide and then transport it to bury it. Presumably on the rocks out at sea, but you could also do it under the United States. They've got some actually remarkable spaces there for putting it. So the takeaway message from this is that this is a wicked problem. There's no obvious solutions to it. There's no immediate fix, because removing carbon dioxide from the atmosphere at the kind of scale needed is going to be very expensive. It's going to be really hard to do in terms of the change in infrastructure needed. This basically means that everybody, every sector, has to focus on how they can decarbonize. And the global governance of this is incredibly weak. So the people who are making a difference are actually the mayors of cities, the businesses and the shareholders who are saying we're not going to do this anymore. And they're putting a lot of pressure on people. And of course, philanthropy is going to play a major role as well. So let's turn to your industry. This could be the same, similar kind of talk I could give to many others, including academics who fly every year to tons of conferences, do lots of networking, and they have been told, look, you've got to reduce that going forward. So I was talking to my colleagues at ETH here in Zurich, and they are already getting direct instruction to reduce the amount that they go to conferences. They have to meet a certain target of reduction in succeeding years. So everyone's having to deal with this. And of course, Charles Eames, who designed amazing furniture, basically thought about how do you design something that fits with constraints. So that's kind of the job we're in, is thinking about how do you design something that will work given the constraints we've got. So this is straight out of Geology bicycle. Those of you who haven't seen it, it's just to go online. It's a British organisation that looks at particular issues of sustainability and how do organizations that are particularly concerned with performances and travel associated with performances, how do they sort of become more sustainable? And it looks at things other than just decarbonisation, which is what I'm really focusing on. But you can see the bit on the right is where you spend your money. And it basically talks about freighting, the instruments, of course, the personnel logistics, and the performance fees and salaries. So let's think about travel first of all. That's probably the most important thing that we should focus on, although we can talk about other things in the discussion. And this shows you roughly what the difference is in flying compared with taking a train, for example, which is down the bottom now. The impact in terms of carbon dioxide emissions per passenger per kilometre traveled is much, much greater if you are flying. So while we recognise that's going to be the case, we have to think about, what are we going to do to try and do something about that. This is another graph from Geology bicycle that basically shows what happens if you travel further. If you travel from the UK or do things in the UK, or if you do it in Europe, or if you do it elsewhere in the world relative to the UK. And it shows the difference between what happens with small, medium, and large orchestras, and quite obviously you can see, not surprisingly, large orchestras travelling large distances are the ones who have the biggest impact on carbon dioxide emissions. So you could say, well, let's change the planes so they actually don't produce carbon dioxide. Good idea. So this is Rolls-Royce. They've actually come up with, they were at COP26 showcasing a brilliant new plane, which actually runs off electricity. It's rather small, as you can see. It takes one person. But it has gone up to a few hundred kilometers an hour, which is great. And they are trailblazing and keen to move forward in that direction. It's not going to be the kind of thing we necessarily yet, but it's early stages, and you've got to give them credit. It's not necessarily going to be the kind of thing that makes a big difference. This is maybe the kind of thing that might make more of a difference, and that's the development of sustainable airline fuel. It's made from waste products, and it's actually got much lower. If you look at the overall cycle in terms of carbon dioxide that is not going to go into the atmosphere as a result of this, you actually reduce emissions by up to 80% compared with conventional jet fuel. So currently, you can actually blend this stuff in quite recently, and Rolls-Royce have actually managed to fly a Boeing 747 with the Trent 1000 turbofan engine running on 100% SAF for 4 hours. So they're moving in the right direction with this. So Rolls-Royce is estimated it'll basically be able to get to 100% SAF use by 2030. This is another, it's not just Rolls-Royce, of course. Boeing and General Electric and NASA are working together on this as well. This is a similar kind of idea, but it's done with a hybrid engine, which they're starting to build, which actually runs off electricity as well as fuel. So these are the ideas that are out there. They're going to take a while to develop. So in the meantime, we've got to think about what we need to do to change things. And so the takeaway message is that a leading component of the carbon footprint of moving major orchestras around the world is going to be the use of aviation. Decarbonising aviation is likely to lead to increasing costs, so we need to be thinking about that. But you can actually expect that the cost of doing this and the efficiency of running these things is going to be less than using regular jet fuel. An alternative is to produce carbon taxes to offset carbon, and people already started doing that, of course. The thing to say about carbon offsetting, which I'm sure will come up in the Q&A later, is that it's pretty much unregulated. It's a market that still needs much further development. And so that's going to happen, I think. And it's quite likely that carbon taxes are going to have to come in. The European Union is already talking about doing this anyway. It's basically whatever we do, the solution is going to end up meaning that traveling is going to cost you more, probably. So let's think about what can I do. So just to finish off. So I guess the first thing to say is that you might want to think about how you can utilize your travel to actually take in more locations while you're traveling. And it could be that there are problems there. For example, it may be that there's competition between local venues in terms of who's allowed to use a particular orchestra. I'm not sure how that will work out, but it strikes me that's the obvious win, is if you can think about ways in which we can move orchestras across to a particular area and have them tour around in that region in more than one place at once to increase the exposure of the orchestra's number of performances while at the same time limiting the amount of air travel. So, and longer stays in a single city, you can do that quite easily in New York because lots of people in New York want to come and hear a concert. So you could actually have several concerts by the same orchestra in the same location over a series of days. That might be a kind of way to think about it. So in my former life, I was at the University of Michigan. Back in first time I moved to America was in 1986. I was a professor at the University of Michigan in Ann Arbor. And the University of Michigan, as you probably know, is very famous because it's got the biggest football stadium in the world. It takes over 100,000 people seated. And it's phenomenal. It was always full, even though the population of Ann Arbor was about 100,000. So they come from all over the country. But you probably also know that it's where you've got the Hill Auditorium and the University of Michigan Musical Society, which is, I was always struck when I was there by the amazing acts that came into Ann Arbor, who people would come from Russia, Europe, wherever, and actually spend time in New York and then come to Ann Arbor and then go off to the West Coast. And you can see why these are the kinds of venues that might be tricky going forward, because these are the ones who are actually going to have to think quite hard about the fact that there's not many people in Ann Arbor to do a series of concerts. So how are you actually going to do that? Maybe you might want to think about getting your orchestra coming from Detroit or Chicago to Ann Arbor rather than actually having people fly in long distances. So that strikes me as something that's going to be quite hard to think about how that's going to happen going further forward. The next thing to think about doing is to actually think about introducing and discussing sustainability at an early stage. It's going to become an increasing problem we're all going to have to work with going forward. And so you might want to think about how do you actually plan a carbon budget for a particular performance, and what could you do to actually make a difference here. So think about what the footprint will be and what you're doing, and then talk about the various people you're going to be engaged with, both in operational and strategic areas of planning to ensure broad buy-in. Because if you don't feel like doing this, and maybe you don't, I can assure you the pressure on you to do so in the future is going to be huge. And so we might as well get used to it early and start thinking about how we do something about it. So building awareness is part of that. You provide training to your colleagues and your teams so that they can be involved in thinking about how to do production in a way that actually reduces carbon footprint. And you can also share in this with other people. So it's pretty clear that public interest in sustainability is growing. There's a lot more interest in it going forward than there used to be. And people actually are looking for answers, and they're looking for organizations to show leadership. So it's an opportunity for your organizations to think about how can I show leadership, because people will pay attention if you do. So the last thing is maybe think about ways in which you might want to partner with organizations, and actually talk to organizations, whether it's venues, transportation, or lodging, and actually check out their sustainability credentials and actually make them part of what we're doing. And again, they may see some advantage in that publicity that might be associated with that going forward. You might want to look at this thing with this, which is also out there for how to make productions more sustainable. So, okay, not the last thing. The last thing is measure your carbon emissions. So this is something there are tools for doing this, and you can actually look again at Julie's bicycle, you can figure out how to do it from there. The offsetting bit we're going to talk about probably later is actually a really important part of this, taking account of what carbon emissions you produce and offsetting them. Offsetting is going to change, I think, a lot going forward, as carbon is going to end up being something that's seen as a commodity that has a value on it, and the cost of carbon offsetting is going to be factored in more rigorously, I think, going forward. So, just to finish off, these are the sort of final takeaways. This is a crisis like we've never had before on this planet. It's particularly difficult because almost everything that we do involves carbon, and everything around us involves carbon pretty much. And we use that carbon and we emit that carbon in so many ways. It's very hard, including in manufacturing, which I haven't talked about. It's going to be really important to figure out ways of doing things differently going forward, and yet we're so inexorably tied with carbon that it's very hard to see how to do that. Young people and succeeding generations are the ones who are going to suffer most from climate change. So this is actually the biggest intergenerational human rights issue we face. And we have to think about what kind of a world we're leaving succeeding generations, our young people. And if you want to engage young people, then you have to show them that you're doing something about this issue. You have an opportunity to lead in this, and I think that's a particularly important part of this. There are lots of things you can think about trying to do, and find ways to connect and get buy-in from other people. And this will actually be, I think, beneficial. because I think people are going to look and say, well, I want to actually support the organisations that are showing strong leadership in this area. So that's it. So we're going to have, so I was going to say, we were going to do Q&A, but actually we've got a panel. Now I've been asked to join the panel. So we're going to have a 5-minute break while we all get sorted out, chairs and mics on, and then we'll have Q&A, but also the whole panel. So thank you very much.